Very good morning, students. This is Jyothishri, JL in Chemistry, AP Balayogi Gurukulam, Chipurpalli. In this video, I am going to teach a special process called adsorption. I repeat, adsorption under surface chemistry chapter in the senior intermediate. Okay, students? The contents of this video are adsorption and adsorption versus absorption, and what are the various factors that affects adsorption process, and types of adsorption process and their differences, and lastly the applications of adsorption process in daily life. Surface chemistry deals with the phenomena that occur at the surface or interfaces. Generally, surface is a layer of separation of two phases. Because of some unbalanced attractive forces suffered by the particles on the surface of solids, they exhibit certain peculiar properties like adsorption, catalysis on the surface. But in this module, we are going to learn about the special process called adsorption. Okay, students? The surface of a solid has a tendency to attract and retain the molecules of the phase with which it comes into contact. These molecules remains only at the surface and do not go deeper into the bulk. That is, due to the attractive forces, the surface has a tendency to remain the molecules on the surface. That is, the accumulation of some molecular species on the surface rather than in the bulk of a solid or liquid is called adsorption. I repeat, the accumulation of some species on the surface rather than in the bulk of the solid or liquid is called adsorption. Here, this is a picture which shows the accumulation of some blue colored species on the surface of a sky colored substance called adsorbent. This accumulation of one substance on the surface of other substance is nothing but adsorption. This picture also tells about the adsorption process. That is, some gas molecules adsorb on the surface of another substance called adsorbent. So, the accumulation of these gas molecules on the surface of another substance is called adsorption. So, students, we can define adsorption as adsorption is a process that occurs when a gas or a liquid solute accumulates on the surface of a solid or a liquid, forming a molecular or atomic film is called adsorption. So, adsorption is the concentration of some gas molecules on the surface of a solid or on the surface of a liquid is called adsorption. Here are some important concepts regarding adsorption. So, adsorption is the process of concentration of some molecules on the interface of two phases, but not going into the bulk of the substance. So, adsorption is a surface phenomena. Here, there are two substances participating in the process of adsorption. One is called adsorbate. So, adsorbate is the substance which is adsorb on the another substance. The other one is called adsorbent. Adsorbent is the substance on which the adsorption takes place. We have to know adsorption is a spontaneous process. I repeat, adsorption is a spontaneous process. So we can say the change in the Gibbs energy for adsorption process is negative. That is, delta G is negative. Also we have to know that the adsorption process is an exothermic process. That is, delta H is negative. Means adsorption process is an exothermic process. This picture is also tells about the process of adsorption. Here some small red colored gas molecules are adsorbing on the surface of another substance. That is, the adsorbate molecules are represented with some red colored markers, and the light green colored substance that is on which the adsorption takes place, that is called adsorbent, is shown by green colored surface. So this is the process of adsorption. Children, now we are going to define adsorbent. So adsorbent is the substance on which adsorption takes place. That is, it is the substance which adsorbs the other substance at its surface. So on the surface of the adsorbent, adsorption takes place. Okay, students? The best examples for adsorbent are activated charcoal, bone charcoal, alumina powder, silica gel, kaolin, and Fuller's earth. These are the best examples for adsorbent on which the adsorption takes place. Now we will define the other term called adsorbate. Adsorbate is the substance which is going to adsorb on the surface of another substance. That is, adsorbate will adsorb on the surface of adsorbent. Catch my point, students? So, adsorbate is the substance which is going to adsorb on another surface. The best examples of adsorbate are generally some gases like hydrogen, nitrogen, and dyes, water vapor, etc. are the best examples for adsorbate. Here you can see the picture of silica gel. Generally, this type of pouches we can see in our handbags, which contain silica gel. It is the substance which can capable of adsorb some water vapor, so that the water vapor do not damage our handbags. So we can see this type of silica gel in our handbags in order to adsorb water vapor. Silica gel is the best example for adsorbent. The another important adsorbent is activated charcoal. The finely divided charcoal acts as a good adsorbent, which is called activated charcoal, which has a capacity to adsorb some gases like hydrogen on its surface. Alumina powder is also a good example for adsorbent. On the surface of alumina powder, some gases like hydrogen, nitrogen will adsorb. Okay, students? So these are all the silica gel, alumina powder, and charcoal or activated charcoal. All these are the best examples for adsorbent on which the adsorption takes place. From all the above discussions, we can say adsorbate is a molecular species or a substance which concentrates or accumulates at the surface of adsorbent, whereas adsorbent is the material on the surface of which adsorption takes place. Adsorption is a surface phenomena. I repeat, students, adsorption is essentially a surface phenomena. Solids, particularly in finely divided states, have large surface area, and therefore charcoal, silica gel, alumina gel, clay, colloids, metals in finely divided states, etc. acts as good adsorbents on which the adsorption takes place. Adsorption process can be observed in the following cases. The first one is if a gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia or sulfur dioxide is taken in a closed vessel which contains some powdered charcoal. Then it is observed that the pressure of the gas in the enclosed vessel decreases and the gas molecules are concentrated on the surface of the charcoal. That is, the oxygen or hydrogen or carbon monoxide, etc. These gases are adsorbed on the surface of the charcoal. It is the clear picture of adsorption process. The second case of adsorption is in a solution of organic dye, say methylene blue, when animal charcoal is added and the solution is well shaken, then it is observed that the filtrate turns to colorless. That is, the molecules of the dye thus accumulate on the surface of the charcoal. That is, the molecules of the dye are adsorbed on the charcoal. It is also the picture of adsorption process. Some more examples for adsorption are the aqueous solution of raw sugar when passed over the beds of animal charcoal becomes colorless as the coloring substances are adsorbed by the charcoal. And the other one is the air becomes dry in the presence of silica gel because the water molecules get adsorbed on the surface of the silica gel. It is clear from the above examples that solid surfaces can hold the gas or liquid molecules by the virtue of its adsorption process. I repeat, solid surface can hold the gas or liquid molecules by virtue of adsorption process. Students, this picture also tells about the process of adsorption. Here, the red colored balls like adsorbate molecules are adsorbing on the surface of adsorbent, which is blue in color. So, the adsorbent is the surface on which adsorption takes place, and adsorbate molecules are adsorbed on the surface of adsorbent. Okay, students, this is the process of adsorption. Okay, students, till now we studied about the process called adsorption. That is the accumulation of adsorbate molecules on the surface of adsorbent. But in some cases, due to some repulsive forces on the surface, the adsorbed surface is removed from the adsorbent surface. This process of removing adsorbed substance from the surface on which it is adsorbed is called a process called desorption. I repeat, desorption. So, desorption, adsorption are quite opposite. Desorption is the process of removing the adsorbed substance and adsorption is the accumulation of substance. Accumulation and removing. These two are quite opposite. So, adsorption, desorption. Okay, students? Okay, students. Now we are going to learn about an important or interesting concept, that is the difference between adsorption and absorption. In adsorption, the substance is concentrated only on the surface and does not go or penetrate into the surface. Okay, so adsorption is a surface phenomena, whereas in case of absorption, the substance is uniformly distributed throughout the bulk of the solid. So, absorption is a bulk phenomena and adsorption is a surface phenomena. For example, water vapors are absorbed by the anhydrous calcium chloride, but water vapors are adsorbed by the silica gel. Catch my point, students? Water vapor are absorbed by the calcium chloride, whereas water vapor are adsorbed by the silica gel. This picture clearly tells about the two processes, absorption and adsorption. If you observe in the first figure, some black colored molecules are absorbed by the red colored substance. So, these black colored molecules are penetrated through the surface and entered into the bulk. So, it is called absorption. But in the second figure, The black colored molecules are concentrated only on the surface of the red colored substance. So it is called, this process is called adsorption. So absorption is a bulk phenomena, adsorption is a surface phenomena. Catch my point, students? Absorption is a bulk phenomena and adsorption is a surface phenomena. This picture also tells about the two phenomena called absorption and adsorption. In the first figure, the gas molecules are entered into the liquid bulk. So the gas molecules are penetrating into the liquid bulk. So it is called absorption. But in the second figure, if you observe, there is a liquid bulk and a solid bulk. The liquid molecules are concentrated on the solid bulk. That is, the liquid molecules are adsorbed on the surface of solid substance. So this is called adsorption. The figure A represents absorption process, whereas the figure B represents the adsorption process. Okay, students? This picture also tells about the absorption and adsorption. Absorption is the substance penetrating into the another substance, whereas adsorption is the accumulation of one substance on the surface of another substance. Okay, students? This is a funny picture which explains both adsorption and absorption. Nowadays we are celebrating our birthday with a cakes. After cutting the cake, our friends apply the cake on our faces. This process is called adsorption. After that, we are all eating that cake, which is called absorption. Just for fun, I have taken this picture which explains both adsorption and absorption. Okay, students? Let us see once again what is the difference between adsorption and absorption. In adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent. While in case of absorption, the substance is uniformly distributed throughout the bulk of the solid. So we can say adsorption is a surface phenomenon and absorption is a bulk phenomenon. A distinction can be made between adsorption and absorption by taking an example of water vapor. Water vapors are absorbed by the anhydrous calcium chloride, whereas water vapors are adsorbed by the silica gel. Is it clear, students? In other words, in adsorption, the concentration of the adsorbate increases only at the surface of the adsorbent, while in case of absorption, the concentration of the substance is uniform throughout the bulk of the solid. Both adsorption and absorption can take place simultaneously sometimes. Then that process is called sorption. I repeat, sorption is the process in which both adsorption as well as absorption takes place simultaneously. Is it clear, students? Sorption is the process where there is adsorption as well as absorption is there. Okay? These two are the pictures of anhydrous calcium chloride and silica gel. This anhydrous calcium chloride is an absorbent. It can absorb water vapor, whereas silica gel is an adsorbent. It can adsorb water vapor. So one is the first picture, calcium chloride, anhydrous calcium chloride is absorbent, whereas silica gel is a adsorbent. Is it clear, students? This picture clearly tells about the two processes called adsorption and absorption. If you observe, in adsorption process, the molecules are concentrated only on the surface. That is in the first figure. And then the second figure, if you observe, the molecules are penetrating into the bulk. So it is called absorption. If both adsorption and absorption takes place simultaneously, then it is called sorption. See students, in adsorption process, the molecules adhere or concentrated to the surface of a material. But in case of absorption, the molecules are penetrating into the material. That is the main difference between adsorption and absorption. This picture explains three processes called adsorption, desorption, absorption. If you see, in the adsorption, the adsorbate molecules concentrated on the surface of the adsorbent. In the second one, the adsorbate molecules are removed from the surface of the adsorbent. It is called desorption. In the third case, the adsorbate molecules are penetrating into the adsorbent. It is called absorption. Students, we have to note that if once the molecule is absorbed, we cannot remove that molecule from the adsorbent. Is it clear? So, what we have studied till now. Adsorbate, the substance which gets adsorbed on any surface is called adsorbate. And the substance on which the adsorption takes place is called adsorbent. When the molecule of a substance are uniformly distributed throughout the body of a solid or a liquid, then that phenomenon is called absorption. Adsorption is a surface phenomenon, absorption is a bulk phenomenon. The removal of adsorbed substance from the surface is called desorption. The phenomenon in which adsorption and absorption occur simultaneously, then it is called sorption. Is it clear, students? Adsorbate, adsorbent, absorption, adsorption, desorption, sorption. These are very, very important concepts in competitive exam point of view. Let us go to the next concept, that is, what are the factors that influence the process of adsorption. Adsorption of gases by solids is affected by, first one, adsorption and surface area of the adsorbent. Second one, nature of the gas. Third one, heats of adsorption. Fourth, reversible character. Fifth one is effect of temperature. Sixth one, effect of pressure. And the seventh one, thickness of adsorbed layer of the gas. These 7 factors influences the adsorption of gases on solids. So let us see what are the factors that influence the adsorption one by one. The first one is surface area of the adsorbent. We all know adsorption is a surface phenomena. The extent of adsorption depends upon the surface area of the adsorbent. With increasing surface area of the adsorbent, the adsorption of the gas or the total amount of the gas adsorbed is also increases. And the second concept is nature of the gas. The amount of gas adsorbed by a solid depends on the nature of the gas. In general, more easily liquefiable gases are more readily adsorbed. I repeat, easily liquefiable gas is more easily adsorbed. And the third one is heats of adsorption. Already we studied that adsorption is an exothermic process. Adsorption is a exothermic process. So, with increase of temperature, the heats of adsorption also increases. Therefore, adsorption is a surface phenomena and the heats of adsorption is more with increase of temperature. Next character is reversible character. Physical adsorption is a reversible process. That is, once the gas adsorbed on a solid can be removed under reverse conditions of temperature and pressure. This property is called reversible character. Next is the effect of temperature. Generally, in some cases, adsorption decreases with increasing temperature, that is called chemisorption. In some cases, adsorption increases with increase of temperature, that is called chemisorption. So, by the rise of temperature can often cause physisorption, which change to chemisorption. Next one is effect of pressure. With the increase of pressure, adsorption also increases. With the decrease of pressure, it causes desorption. I repeat, adsorption increases with increase of pressure, and with decrease of pressure, the desorption takes place. And the last one is called thickness of adsorbed layer of the gas. Physically adsorbed gas forms only one molecular thick layer, that is called unilayer. However, in chemisorption cases, with increasing pressure, multimolecular thick layer is formed or multimolecular layer is formed in case of chemisorption. These 7 are the factors which influences the adsorption of gas on a solid adsorbent. Is it clear, students? Basing on the molecular forces present in between adsorbent and adsorbate, the adsorption processes are classified into 2 types. The first one is called van der Waals adsorption or physical adsorption or physisorption. And the second one is called chemical adsorption or chemisorption. Physisorption and chemisorption, these are the 2 types of adsorption processes. I repeat, students, depending on the nature of forces between adsorbate and adsorbent, adsorption is of 2 types, physical adsorption or physisorption. If the forces between adsorbate and adsorbent are weak van der Waals forces, then it is called physisorption. And second one is chemisorption or chemical adsorption. If the forces between adsorbate and adsorbent are strong chemical bond, then that type of adsorption is called chemisorption or chemical adsorption, which is a strong adsorption. These are the 2 types of adsorption processes. Physisorption or physical adsorption is a type of adsorption in which adsorbate concentrates to the surface only through weak van der Waals forces or weak intermolecular forces, which are also responsible for the non-ideal behavior of the real gases. And the second one is chemisorption is the another kind of adsorption in which the gas molecules or atoms are held to the solid by strong chemical bonds. For example, hydrogen is chemisorbed on nickel. So these 2 are very important, students, physisorption and chemisorption. Physisorption is a weak adsorption, chemisorption is a strong adsorption. So let us see what are the differences between physisorption and chemisorption. So physisorption arises because of van der Waals forces, whereas chemical adsorption is caused by the chemical bond formation. Physisorption is not specific, but chemisorption is highly specific. Physical adsorption is reversible in character, whereas chemical adsorption is irreversible in character. The enthalpy of adsorption is very low, that is about 20 to 40 kilojoules per mole in case of physisorption, but the enthalpy of adsorption is very high in case of chemical adsorption. It is about 80 to 240 kilojoules per mole. For physisorption, low temperatures are favorable. That is, it decreases with increase of temperature. I repeat, low temperature is favorable for physisorption, whereas high temperature is favorable for chemisorption. That is, it increases with increase of temperature and then decrease in case of chemical adsorption. In case of physical adsorption, no appreciable activation energy is needed. I repeat, no need of activation energy in physisorption. But there is a high need of activation in case of chemical adsorption. In physical adsorption, multimolecular layers are formed. But in case of chemical adsorption, unilayers or monomolecular layers are formed. These are very important in case of IPE. What are the differences between physical adsorption and chemical adsorption? So students, once again, you go through this very important table. Okay? Dear children, this picture also tells about the process of adsorption on adsorbent material and desorption process, and extreme left, it is a monolayer adsorption which is nothing but chemisorption, and extreme right bottom figure indicates multi-layer adsorption which indicates physisorption. So monolayer adsorption is chemisorption and multi-layer adsorption is called physisorption. Okay students? Coming to the last concept called applications of adsorption. Means in various ways how the adsorption process is useful in our day-to-day life. The first one is adsorption process is very much useful for the production of eye vacuum. Vacuum is nothing but the medium without any substance or without any gas or any other substance. And the adsorption process is also used in the preparation of gas masks. Gas masks. This apparatus means gas masks are used to adsorb poisonous gases. For example, sulfur dioxide, sulfur trioxide, and thus purify the air for breathing. So, gas masks preparation is mainly based on the process of adsorption. And the third important application of adsorption is for the desiccation of dehumidification. These substances can be used to reduce or to remove water vapors or moisture present in the air. Already we have learnt that silica gel and alumina are used for the adsorbing water vapor. That is nothing but dehumidification in electronic equipment. And the fourth important application is removal of coloring matter from the solution. Charcoal means animal charcoal removes colors of the solution by adsorbing colored impurities. That means the colored impurities are adsorbed on the animal charcoal. And second one, animal charcoal is used as decolorizer in the manufacturing of cane sugar. And the fifth application of adsorption is in the process of heterogeneous catalysis. Generally, the catalysis in which the reactants and products are present in different phase is nothing but heterogeneous catalysis. Mostly, heterogeneous catalytic reactions proceed through the adsorption of gaseous reactants on solid catalyst. Okay, students? The next important application of adsorption is separation of inert gases by Dewar's method. It is fully based on the process called adsorption. Due to the difference in degree of adsorption of gases by the charcoal, a mixture of inert gas can be separated by the process of adsorption on the coconut charcoal at different low temperatures. This process of separation of inert gases by the adsorption process is called Dewar's process. Coming to the next important application of adsorption is softening of hard water. We know that hard water consists of so many salts like calcium, magnesium, chlorides, sulfates, bicarbonates. The hard water is made to pass through a column packed with zeolite, what we call sodium aluminum silicate. Then calcium plus 2, magnesium plus 2 ions which are responsible for the hardness get adsorbed on zeolite surface, exchanging sodium ions. Thus, we can remove calcium ion and magnesium ions from the hot water. The exhausted zeolite is regenerated with 10% of the sodium chloride solution. By this way, adsorption process is used for the softening of hot water. Some more applications of adsorption are: adsorption process is very much useful in curing some diseases. Number of drugs are adsorbed on the germs and kills them, or those are adsorbed on the tissues and heat them. This way, adsorption process is very much useful in curing disease. And next one is froth flotation process. We can concentrate some sulfide ores by the process of adsorption. And lastly, the important application of adsorption is in dyeing process. Many dyes get adsorbed on the cloth either directly or by the use of mordants. So these are all the various applications of adsorption in our day-to-day life. Okay, students? Okay, students, till now we studied about what is meant by adsorption and the process of adsorption, and what is the difference between adsorption and absorption, and what are the various factors that influence adsorption, and what are the types of adsorption and their differences. Finally, what are the various applications of adsorption process. This is about our surface chemistry chapter adsorption process. Okay, students, I hope all of you enjoyed my lesson, and thank you. Thank you very much.